um, and go through some of the uh, engineering behind the use of the feature. So we'll get started. Again, my name's David Booker. I've been doing traffic signals and operations and advanced traffic systems now I'm in my 30th year. I have timed or programmed over 3,000 intersections throughout North America and the Caribbean. And for the past 15 years or so, I've been providing advanced signal timing training to hundreds of traffic engineers throughout Canada. Uh, Dr. Zong and I got introduced, I guess, back in June of 2020. I cannot remember how that happened, but you know, good fortune, and we've been working together since. A little bit about the company I work for, Associated Engineering. Uh, we're we're situated across Canada. We have 21 offices and approximately 1,100 employees. Uh, we are not all transportation people. It's a large engineering firm, and so it's up to our transportation group to assist many of these other disciplines throughout the company. We get involved with buildings, energy, environmental infrastructure, transportation and water. We do a lot of support for our highways and bridges divisions, as well as our infrastructure and water divisions for large scale contracts. We get involved with planning, design, and traffic management plans. My experience with WaySync again goes back to 2020 and uh, several projects throughout Canada. I've used it on over the past few years. Some large projects in the Greater Toronto area involved with City of Oakville, City of Mississauga, the town of Aurelia, all in southern Ontario. And then another large project we did a couple years ago with Dr. Zong's participation was out in Saskatoon, Saskatchewan. And that worked very effectively out there. And again, we do a lot of traffic management plans for various AE disciplines. When I got thinking about how I wanted to present this and the interaction with the return to green feature, I kind of wanted to take a step back and make sure we got everybody in the group a good understanding of what we're trying to do with that particular functionality in the time-space diagram. So I took some of the training material I had from the advanced signal timing course I have, and I I integrated that into a presentation where we can show the setup of an early return to green and how that functionality within WaySync interacts with it. So we'll look at the functionality of a time-space diagram, different types of coordination patterns, timing for two-way progression, probability of early return. Then we bring up some WaySync graphs and the early return to green functionality and how that ties in. And then finally, avoiding the dilemma zone. And for those of you that's not familiar with that, we'll have a quick explanation on that terminology. Before we get into this, I have a tendency to ramble on about traffic. I can do it all day. So if you are not sure about something that we're talking about or have a question, please don't wait. Jump right in. Happy to discuss it and answer your questions immediately. So the functionality of a time-space diagram. What is the purpose of a time-space diagram? How to avoid the dilemma zone? What are different types of time-space diagram patterns? Well, the purpose of a time-space diagram is essentially to provide a visual representation of vehicle control, not unlike some traffic. So essentially, how I go about this process is I create a time space diagram. I know in my head how I want traffic patterns to operate on street. And then I take that information, I can import it or export it back into Synchro and run a sim traffic scenario to see if what I'm envisioning in my time space diagram is actually working correctly in a model situation. The time space diagrams should not be used simply to make pretty green bands. I tell this to everybody I work with. Yes, it's wonderful that we can go in there and make coordination patterns, but time space diagrams themselves are not to create beautiful green bands and say, here you go, traffic's going to move. We need to provide consideration in our traffic flow from node to node to make sure that A, we're moving traffic efficiently between those points, and we're moving traffic safely in both directions between each of those points. And we're going to touch on that a little bit later here. So what does a good time space diagram look like? It moves traffic. It moves traffic with minimal delay in the primary direction of traffic. It does not overly affect the movement of traffic in the non-primary direction, so that if you may have a wonderful green band in one direction or good flow bands in one direction, make sure that you're not compromising the operation or the safety of flow in the opposing direction. It considers travel speed fluctuations in the traffic pattern. It accounts for sinks and sources throughout the network. Not all traffic moves smoothly down an arterial roadway. There could be, you have to account for traffic entering the traffic stream or leaving the traffic stream and slowdowns that occur because of that. It does not ignore that coordination may be best served in a nonlinear route. Your coordination pattern may come off of a highway, or it may come off of a major left turn off of another network. It accounts for vehicle makeup in the traffic stream, which is very important. Your traffic stream is not completely made up of vehicles. You have buses, you have heavy vehicles, transport trucks and such. We need to be able to account for those in our traffic stream through the time space diagram, because especially if you have a higher percentage of heavy vehicles, they may be blocking your exit maneuvers at your intersections, in which case you have to account for that. It does not deliberately put vehicles in the dilemma zone, either in the primary or opposing directions. So what is the dilemma zone? For any of you not familiar with it, it's that point where you're approaching a green indication and you suspect it's going to go red at any point. And you're far enough back that it goes amber and you go, oh, okay, I knew it was going to go, and you hit your brakes and you stop. Or you get to that point where it's, well, should I stay or should I go? And you have to make that split-second decision of, can I make it or not? And that's where you fall into the dilemma zone. And when we're creating our time-space diagrams, we want to make sure that we are deliberately not forcing platoons of vehicles into that situation in a downstream signal. So an example, time-space diagram is used to represent your expectation of vehicular movement along a coordinated network. And here's an example of a time-space diagram in WaySync. The functionality in WaySync is fabulous for adjusting time-space diagrams. It's very intuitive, very user-friendly, and it makes our job much easier. For those of you who have ever used the synchro time-space diagram, this is absolutely wonderful. Types of coordination patterns we have to consider within our time-space diagram. There's three types. There's beginning of green, end of green, and staggered coordination. So beginning of green coordination is simply you leave at time 0 of your green indication at one intersection, you get to the next intersection, it goes green, next intersection, it goes green, and so on and so on. Beginning of green is wonderful, especially you have simple coordinated networks. End of green, this is where you take the essentially the start of your amber point and you coordinate your amber point so that you're coordinated intersection 1 amber, intersection 2 amber, intersection 3 amber. End of green coordination typically works much better with a network that consists of a lot of semi-actuated control. And again, early return to green because of semi-actuated control, and this takes advantage of that. Staggered coordination is simply if you have multiple entry points along your coordinated network, you highway ramp turning onto a network, another arterial turning onto a network that you need to consider. So you may have coordination that staggered, and you could have two distinct platoons going through your network from different starting points. So the benefits of each type: good for one-way streets, good for fixed time roadways, end of green or amber, better two-way progression, less intersection queuing, good for semi-actuated controllers, and benefits of staggered, accounts for heavy sinks and sources, and accommodates irregular routes. Now, we want to maximize our mainline green time for bidirectional progression. So how can we do that? Well, where can we find more green time for the mainline movement? Well, we can increase the cycle length and go to longer cycle lengths to give bidirectional progression. We can take from our left turn movements, we can take from our side street movements, we can look at reducing lost time, and we can reduce our pedestrian movements. Not ideal, but we can do that. The two we're going to look at as part of our return to green feature is taking that time from our left turns and our side streets. This is where we tie into our synchro or our WaySync functionality. What is early return to green? Well, I've called it through the years probability of early return. So what is probability of early return? It's an estimate, not unlike the probability of precipitation, that allows a traffic practitioner the ability to take advantage of early returns to mainline green by semi-actuated intersections. Pretty straightforward. Not all the time is used for your left turn or for your side street. Let's make use of it. It's used to set the time-space diagram, typically in the minor direction of traffic flow to allow for improved two-way progression along the corridor. So estimating the probability of early return, and this is important because this is how we're going to adjust our early return to green feature in WaySync. So how do we adjust it accordingly? Well, it's very dependent on the number of pedestrian calls. You have a lot of pedestrian calls, you're not going to return to Main Street green early because side street's going to be servicing your peds. Very dependent on the side street left turns. Left turns generally need more side street split time. So your probability of early return will change throughout the day and can be reflected in each time-space diagram. So we're going to set up different time-space diagrams, probably for each peak period. The estimate should be taken for each intersection, for each time period. So how do we estimate that? Well, the estimate should be simple. The WaySync functionality is set up simple like this, so it works very well. Think of it as a percentage where 0% the side street will never return early, or the 100% side street will always return early. 20 to 40, maybe it does. 60 to 80%, well, maybe once in a while. Maybe we don't want to account for that because it's not going to happen too often. So we've estimated the side street will return early, but how early will it return to Main Street? So this becomes the second part of the question is, yes, we know it's going to return early. Maybe 80% of the time it's going to return early. But if you've got 25 seconds of side street and your min's 10, are you going to come back after the 10? Or are you going to come back after 22 of the 25? So there's some leeway there as to how early it returns. Go out, take a look, get a good estimate during your peak periods, and then we can apply this factor to our early return in WaySync. So here we get into our WaySync, and if you're familiar with the time space diagram screen in WaySync, you'll notice that this is a segment of our right side bar, and these three dots here are our early return to green functionality. And if I pull up the detail, it shows all of our intersections and how much percentage we want to take away on a cycle by cycle basis from those movements in order to apply to our Main Street movement. And again, this comes back to, for 20 years, all I did was take a sheet of paper and hold it up to the screen and say, this is what the graph's going to look like. Now we can actually make those adjustments in WaySync. Very useful functionality. So if I use my, this is just a segment of the time space diagram that I copied over. If I look at the current timing for Menkes Drive, and this is Menkes Drive here. I have a little bit of green band going through Menkes Drive. It's not very useful. It's just a tiny intersection out on my large arterial roadway. I decide, well, you know what? I've been out there. I know they're only servicing 1 or 2 cars at a time. I can take 80% of my side street phase and reallocate it back to Main Street. So what does that do? Well, if I look at Menkes Drive now, I've taken that 80% of my side street time and I've reallocated it back onto Main Street. And so now this graph, or this through flow pattern, is much more accurate to real conditions out on street. So this becomes very important to us as to how to evaluate how the real traffic movement in both directions are going to operate on street. From there, I can and it doesn't have to be, well, obviously it doesn't have to be just one intersection. If you have many intersections, I may want to change a bunch of these to different percentages based on what we've observed on street. And that way it gives you a much more accurate representation of the flow between intersections in your graph. So we've done that, but we want to check one more thing. I'm going to go back to the dilemma zone. Very important. If I look at Menkes Avenue here, I am leaving Bramalea Road at the start of green in this direction, and I am heading down to Menkes Road, and the first 1 or 2 cars is hitting a green indication at Menkes, but only the first car or 2 are getting through. And then I'm going to a red indication. So I'm taking my platoon of vehicles from Bramalea, driving them into a supposed green indication, but once the platoon gets there, the majority of the platoon's having to slam on their brakes because they're getting caught by the amber indication. We want to make sure when we're creating our graphs in time-space diagram that we do not deliberately create this condition. So it's very important, even though we have beautiful graphs in our primary direction for flow, to make sure that we're not doing this in the opposing direction. Many times I've taken networks that have 10, 12, 15 intersections that flow beautifully in the primary direction. And I go back and I go, you know what? I've got this condition here in the opposing direction. I'm going to create havoc out there. It's dangerous. It's not suitable. I'm going to go back. There's two things I can do. I can adjust my, oh, I want to go back. Will let me go back? Might not let me go back. Anyway, it will allow me to adjust the offset point so that that condition does not occur in the opposing direction. Or two, you split your network and create two coordinated networks rather than one, so that you redefine a network midway so that you get better operation and safer operation over the course of two smaller networks than one longer network. So there's two ways you can go about that. Is just be cautious about what you're doing when you set up that graph. So in summary, we want to establish the best coordination strategy for the network. We want to look for natural breakpoints in the coordinated network. Is there something that is going to dictate? It could be a bridge, could be railway, could be literally anything. Where's a good start and end point for your network? Take advantage of early return to green for bidirectional progression. This is truly an amazing feature within WaySync. Encourage everybody to use it to its fullest capacity. And then ensure the coordinated pattern does not create a dilemma zone condition. And we create safe TSD graphs. So that's my quick presentation for the group. If you want any questions, or we can move on.
Thank you, David, for an excellent presentation. Yes, now we have time for some questions and answers Q&A session. Anybody, feel free to ask David or myself any questions you may have.
I have a question.
Yeah.
So when you get the early return to green, when you decide what percentage you're going to use, does it matter at all how early it is? What do you consider an early return? So if it's not that much early, do you consider it like you don't really count that, so it won't count towards a higher percentage? Is there some sort of criteria you use? How early is an early return?
Generally, I'll use some form of. I go for anytime I'm doing a signal timing assignment. I'll actually I go out on street and actually take a look at it. I hope most of you do, just to get a sense of what's happening at the intersections, especially during the peak periods. You can get a sense pretty quickly especially on minor streets, what the typical usage is, and how much time they need. You may have a side street that needs 28 seconds of pedestrian time, but one pedestrian an hour hits the button, and so you're not worried about them. And you only have two vehicles show up on generally each cycle. Well, if you got two vehicles, I generally run a 10-second minimum. So you're going to service your 10 seconds, and then in a typical cycle, they're going to gap out and come back to Main Street. Well, in that case, I've got a 28, I got a 28 seconds of PED, 8 seconds of clearance, 35 seconds. I'm running a 10-second minimum, a 3-second gap out, 13, 26, 39. So approximately 60%. I'm coming back 60% early to Main Street. And that is the percentage I could use in that functionality with WaySync, the percentage of early return to green, 60%, because so the way the WaySync operates is not, does it return to green and how often? That's kind of the first step before you even decide on making that adjustment in WaySync. It's considering the second step of how much of that side street split time do I want to take away? And so if your typical condition is a few cars, run side street minimum, take that time away and assign it back to Main Street and see how that looks in your graph. Again, you may have extra cars, some cycles. That's okay. That's okay. Maybe that's not a typical condition. The controller's still going to service them. They're not going to gap out. We're not affecting them in any way. We're trying to simply create a typical condition in the graph to better suit the movements out on street.
I had a question, if you can hear me.
Yeah.
Yes.
I thought you had mentioned creating two smaller coordinated systems if you run into an issue like a dilemma zone in the opposite direction. Can you talk about what that looks like? I mean, are you referring to a different cycle length for a segment going forward?
No, it doesn't. No, it doesn't have to be different cycle length. It doesn't have to be different cycle length. But I actually had this conversation with David Shampoo a couple years ago. I think we were doing a training session together. And is it better to stop or slow down vehicles at multiple intersections and create multiple small delays throughout your network? Or is it better to create one large delay where you regather the traffic up and give them better coordination through the remainder of the network? And I think we both agreed that one controlled stop in your network is better suited to most networks because it provides us the control to maintain that group of that platoon of cars without losing them or having them spread out. And so if you're in this condition of a dilemma zone and you want to avoid that, look at if you can adjust your offset to eliminate that, wonderful. If you can't, then look at breaking up your network at that point and deliberately creating a safe stop for your full platoon. Don't break the platoon in half. Turn the red on way early so that the front of the platoon's not even there. You stop the entire group and then gather them up and move them forward for the remainder of the network. Doesn't have to be a different cycle length. You can run the same cycle length.
That makes sense. I think that sets up a better expectation too, rather than the platoon wondering or some of them wondering if they're going to make it and
Absolutely
maybe prevent some of that speed up.
Yes.
Got it. Thanks for clarifying.
Absolutely.
Okay, Logan have a question. So what additional features to the early return to green options would you like to see in the future version of WaySync?
Oh, sorry. What features I would like to see?
Yeah, early return.
Oh.
So you talked about early return. Do you think you are pretty happy with what we have, or you have additional, features you would like to see?
You know what? It suits 90% of the conditions that I'd come across. The fact that we're able to do those scenarios and save those scenarios to take a look at that is very valuable. I actually haven't given a lot of thought on taking that beyond that. Unless you're getting into real-time time-space diagrams in the future, then there are more options we can do with that feature as we get into real-time time-space diagrams and actually adjust that feature on a cycle-by-cycle scale. but that's something we can look at in the future.
Okay, thank you. Logan has a second part question. Probably I sense he has something in his mind. This maybe, I want to kind of open to everybody. So are there any other general features you would like to see to be added in WaySync? So, for everybody, if you have, something in your mind, there's something I would like to see, send that to me, make a list, send that to me, and we will work toward that. And so there's something we are working on now. I will talk about that later. But Logan, you put up this question. I believe you may have something you want to say. What other features you would like to see?
Sure. You aren't wrong. So as far as the detail breakdown, it doesn't currently go by phase. It goes just size streets in general and lefts in general. There are certain side streets that, will have a lot of vehicle traffic coming from one direction and not the other. But
That's true. Yeah. Right now
which, I
you're
mean,
just combining everything on the
you
side.
absolutely can. It gets more granular, and have like sometimes having one setting just simplifies things. But I was curious if anybody else felt that like they wanted to have more control or more detail.
I have a comment on that. I haven't done it lately, but last year or the year before, I'm trying to remember, one of the agencies that we work with, they in their coordinated timing plans for their maximum modes, they don't always run max inhibit. Instead, they'll run a max 1 or a max 2. And if you do it, in my opinion, if you do it right, and you have good working detection, and you're choosing to run your fixed force off with it, you have sort of greater granularity of where and how you want time to be passed or jerked around throughout the cycle. And then obviously equates back to what early return percentage you want. So in order to show that agency visually on the time space diagram, like kind of what that means, and especially in the synchro days, I always had, it was just a pain in the ass because I had to almost make like 2 different diagrams for everything just to be able to show like a before and after. And then in those cases, half the people still didn't even get what they were looking at. So it to this day, I would love it with those agencies if there was a way that in WaySync you could almost teeter back and forth between, okay, if I'm running max inhibit, these are my splits, right? And then my early return percentage, right? Versus if I'm running a max 1 in an alternate phase timing table, and I know that I want certain movements in the sequence to absorb a certain time before the early return, then what does that look like? I know that's very complicated and very granular, but it's just something that I've been thinking about. I guess the last thing I'll say is a lot of people that I run into, they just simply don't get it. They don't understand what they're looking at. They try to oversimplify it. Then they blow you off. Then they don't give you the time. They don't give you the work. I'm saying like I'm more on the private consulting side to agencies. And then on the agency side, when I was on the agency side, it was so difficult to quickly produce these beautiful pictures. Now, WaySync really, really made it easier. But even with that, it still made it hard to get in front of the right people to keep people's attention to do all this. So anyway, great presentation, Dave, too. And great question, Logan, on that. Yeah.
Thank you, David.
As far as I just wanted to add, the general feature that I would most like to see added is being able to delete a signal plan from every intersection on a corridor with like one button instead of having to go to each intersection and delete it one by one.
Delete one timing plan?
So like if you have an AM peak timing plan, to be able to delete that from the corridor all at once instead of having to open up each intersection and delete the timing plan one at a time.
Okay, did you use the subsystem editing function?
Okay.
Okay, let me show you. Make sure I understand. So this corridor, let's say this can you see my screen?
Uh-huh.
Okay, so this corridor has 3 timing plans, right? You want to delete the AM for all of them. That's your question?
Okay. No, I see now that there is a way to do what I had been looking for. I hadn't been to that menu.
You just you see it's a edit subsystem
Mm-hmm.
and timing plan here. You just I believe you can just delete it, then it should be all deleted.
Perfect. That
Yeah, so
the feature that I wanted, I already got.
okay. Yeah, so there might be a lot of features already there. So I know you have been using it all the time, but for others who have not really used it, I think everything probably is new to them. So I don't want to say too much unless you ask a particular question. I will tell you if you already have that or not.
I have a question.
Yeah.
Yeah, this is Greg KB.
Uh-huh.
Um,
Right.
Hi. Yeah, it sort of refers to the max, getting away from max emits and putting in your max ones and twos. We do that also. Um, and then also the early return to green as far as using the percentages. I mean, I think that we could take that, whatever max you're using, turn it into a percentage, adding it to your side streets, left turns to be able to show the early return using that max 1 or 2 or 3, whatever you're using. Also, as far as using those percentages to show an early green, wouldn't it? I mean, don't your trajectories are recorded on the time space diagram, aren't they? It's been a while since I've seen them.
Yeah, if you do the field runs, yes.
Right. So wouldn't it be really beneficial to do the field runs? That way you'll see your trajectories going through your reds, which means you had an early return, and then adjust your percentages to accommodate to more realistically show the runs going through your time space diagram and doing it that way.
That's a good point. I think the issue is if you do the field run, it's only one run or couple of runs. You may not capture every cycle, and you are in a particular position in the band, so you don't always see that early return.
Oh, you can't see the collection of all your runs as you're doing them or after you've done them?
Okay, let me show you where I have some real data. Okay, maybe. Yeah, I have lots of data for Vegas, so I will show you. The early return, each intersection could have early return, right?
Right.
So if you do the travel run, you drive from one end to the other end. So that trajectory, if it goes in the green, happens to be the green, then you really don't know when the side street green returned to the main street. It just the run. We can put multiple runs, but still you won't be able to capture every intersection. Okay.
But when you're looking at the trajectory, isn't it showing it going through every intersection?
Yes. Okay. Let me show you a couple of those runs.
Now those trajectory runs, they will show you traveling through an early return, but you may not know how early that return was because you may have left early from the upstream intersection. So you're already in advance of your green band. you're already ahead of it. And so that secondary early return may not have been 20%. It may have been 60 or 70%. It's tough to tell just by driving through because each early return compounds to the next one.
Yeah, for example, here, you started at upstream. Obviously, there's no early return. But once you pass this one, it happens to be green. So whether this intersection you got early return or not, you won't be able to know. Although from this direction, it happens to be red. Yes, in this case, you will know you didn't get much early return. But you have to really examine one by one, right? The case is also here going through, but you don't know when the actual green started. Unless you hit a red. You hit a red, then you kind of know if there's an early return or not. I'm not sure if I answered the question.
Yeah, that's why I asked if there was one where you had multiple runs. I mean, here you know, I could see you have two or three, but once you collect a lot of them, you could see a trend of your early returns, I would believe. I mean, that's how we've been doing it, to where you'll have one intersection that's very obvious, like I believe you explained it earlier, where there's only a couple cars and hardly any pedestrians. And if your time-space diagram was designed for those pedestrians, that the progression would not be that good. You really need to show the early return and then work from there. But I saw in that last time-space diagram, it looks as though you're using all of the side street splits. So, you know, I didn't see a place where you would use it on that last diagram yet.
Yeah,
But
this is
if on this one here you show one going through, you know, towards the beginning of the red, then I would say that would be one you'd probably want to look at
yes.
carefully. Right.
Like in this case, even though we have so many trajectories, but they all go through when it's green. So there's no way to tell whether this intersection got an early return or not, right?
Right, but we wouldn't be concerned over that one though, would we?
Oh, you mean the other where you hit the red, like here?
Well, that we hit a red there because the end of the platoon didn't make it through, right?
Yeah.
Yeah.
Yeah, early return doesn't help you in the primary direction because you're actually setting up your coordination pattern for that direction, and you want to capture as many vehicles as possible in that primary direction. Where the early return really benefits you is that opposing direction, where you can benefit from providing that extra Main Street time that they normally wouldn't get to get through those minor intersections where you don't want them to get caught.
Okay, I see there's another question. So when we optimize, the process takes into account the data collected, the runs in this case. Is it, can you clarify? I don't. It is. We'll ask this question. When we optimize, the process takes into account. Okay, here's the question. The data collected, the runs in this case. So can you clarify this? What do you mean? The process takes into account the data collected. I guess your question is when we do the optimization, whether we use the data collected in the field to do the optimization. So if this is your question, the answer is no. The field data collected is only for performance, for evaluation purposes. Yeah, Nestor asked, how did I get all this data? this many trajectories. This is all coming from, used to be the Weizhou company, now it's a Streetlight. So Streetlight sells the raw data, but you have to process it. So we have a software to process the raw data to get whatever segment you want, whatever time period you want, and then lay it on top of the time-space diagram. And this is the case we did for Las Vegas. Any other questions? Any other features for everybody? Any other features you would like to see? No? You think this is perfect too? You don't, there are no more features you need?
Yeah, Dr. Chan, I was
Yeah.
wondering on the counts, what are they actually doing? I mean, I just heard that I've been behind on all the upgrades, but I heard that WaySync is you can input counts into the
Oh,
software.
input counts.
How does that handle that?
Okay, you can see my screen. You still see my screen, right?
Yes.
Okay, if I click one, okay, WeSync allow you to do the optimization with without volume. So if you have volume, you could come to this timing window. So there's a cycle optimization. Right now, I don't have any volume here, but you can input your volume. So double click, then you can specify how many lanes you have. Say it's 4 lanes. So what's the volume? You put your left turn volume, 200 through, let's say 500, right turn 50. Then you specify your configuration. There's left turn, 2 through, and maybe through right shared. And then you put into the geometry. Then we can do the cycle split optimization. We'll tell you based on your geometry, your phasing, your volume, what cycle it should be. Okay, I don't have any volume here, so this is how it works. So you can have 4 lanes there, and then left turn volume, through volume, right turn volume. So this is where you put your geometry. There's also some default here. What's the peak hour factor? Your base saturation flow rate, percent heavy trucks. Okay, it's not as sophisticated as a heavy capacity manual, but should give you a pretty good ballpark estimation. And then, yeah, you have to have some numbers in order to run it. I'm just putting some dummy numbers here. So right turn. Just putting some dummy number here. And then once you have that, you click the cycle split optimization. Will tell you, based on this, you need a 120-second cycle, and this is your volume capacity ratio. And this is also, there's a check. Do you want to satisfy the pedestrian crossing time or not? So if we don't care about the pedestrian, this is your split. If you put a pedestrian there, then this is your split. And cycle, you can always change that. You can re-optimize it. And you can also manually adjust that. Once you're happy with it, you can save or get back to the original one. So this is how you optimize the cycle and split for each individual intersection. Once you have all of them, then you can you do the same thing for each intersection. Then we have the optimization, where you can optimize things like optimize. So there's a cycle-based optimization. So this is where you can specify the mean, max, the increment, and then you want to optimize the split, or you want to just use the existing. So this will give you the optimization considering volume if you have.
Okay, I got it.
Christina,
Question, Satya.
Yeah.
Are you saying yeah to me?
CoCap?
Yeah, this is CoCab. Hi.
Yes.
That description that you just went through, with the estimation of the cycle length and splits, what kind of base is that? If it's not highway capacity manual, what's the
No, it's
methodology that you're using?
okay. It's not based on the capacity manual. Okay. Hopefully everybody knows this new feature. So from the time space diagram, you double click the red bar, you can get into this timing window. Okay. The optimization, you can see our input is very simple. So you put this is the default saturation flow rate. You can change your percent heavy trucks. Okay. So our methodology is based on this target V over C. So
Okay, so it's ICU. Is it ICU methodology, intersection capacity utilization?
yeah,
Okay,
volume
got it.
capacity ratio.
Yeah, okay, gotcha.
Yeah.
Thank you so much. Thank you for clarifying.
You're welcome. So this way, this is how we do signal timing. We don't want to have any movement or phase to be oversaturated. So you set your target. Yeah, this is your target. Okay, on the main street and also on the coordinate phases and the non-coordinate phases. Okay, then we gave you the cycle. It's suitable for signal timing purposes, not the level of service type of analysis.
Yeah, I got it.
Question.
Yeah.
Based on this one too, when we do optimization of a corridor, let's say, and we add, for example, the volume, and we have runs that we have collected. The optimization is gonna take all this into account, or it's more theoretical, meaning it's gonna just base it on the, let's make main line, let's say, depending whether you want to have a balance, or when you wanna favor one direction. I just wanna understand that.
Okay,
I don't know if I was clear.
Yeah, the optimization is based on to maximize the bandwidth, the main street bandwidth. There are few options. Okay, I will show you the optimization function. You mentioned the directional preference. The volume, if you have volume, that is when you decide to change the cycle length. If you don't change the cycle length, you already know your split and cycle. So we optimize the offset and the sequence to give you the maximum bandwidth. If you have the volume, you would decide to change the cycle length, then the program will search which cycle length will satisfy the criteria you specified, like the target V over C. And then based on that one, will give you a range of the cycle length. Then you can pick which one you like. I think I have a.
Does that say the same idea applies for the splits? Let's say that I'm not necessarily changing or want to change the cycle length, but would that give me also, I mean, would this be recommended for splits and to kind of improve coordination?
Yes, if you want to change the cycle and split, then you must have the volume. Yes, we will. That's what the cycle split optimization. That's what it does. It will tell you if you decide to use a 120-second cycle, this is the split. If you decide to use 130-second cycle, this is the split. Okay. Yeah, the optimization, we do have this, you balance both directions. You can favor in one direction or the other. But this kind of optimization is not taking into consideration the volume. The volume is only for determining the split and the cycle. And then you decide you want to favor the eastbound, or you want to favor the westbound, or you want to do balanced. So we do give you these options. Like this one, if we say run a balanced, so you see now the bandwidth is kind of balanced, gave you 24 seconds in one direction, 24 seconds in the other direction. You can also run favoring eastbound direction like this. So eastbound, now you got the highest possible, which is 43 seconds. And then the other one obviously is not doing very well. Okay. And then
Can we, I'm sorry if I interrupted. Can we determine, let's say that we want to optimize one direction, let's say the eastbound direction. Can we set some sort of percentage? We can, okay.
no, not now. Okay. In
now,
that
okay.
case, this is what I prefer. I want to do a balanced, but I want to do this kind of we call it a partition. We break them into like two segments. This is what I prefer. Okay, I will show you what I mean here. See, the entire corridor is broken into two segments. So you decide to go go the other direction. Okay, so you got a through band going one direction. The other direction, so this is our virtual trajectory. You can see you still have a pretty wide band for this segment, but you are going to make one stop here. Once you make one stop, then you go through. You can handle a wider band, handle more cars. This is personally I prefer this way instead of you say this direction gave me 70%, this direction gave me 30%. But if everybody has a strong feeling, you can specify the percentage. I think we can work toward that.
Will that partition setting only give you one break in the corridor?
Right now, yes. So,
Okay.
yeah, you obviously, you cannot have a very long arterial. Currently, you only break into two.
So I'm assuming if there is one segment, I mean, there is one intersection that says some sort of bottleneck that you have long queues, the software is going to kind of make the partition there. Is that how it works? I'm just trying to understand how it works.
Okay, you can specify manually. Okay, you can see here, manual partition. You can do automatic, you can do manual. When you do manual partition, see manual partition here, you can specify, I want to break at this intersection. So now you got group one, group two. You can manually do this. So you decide. Program that doesn't look at whether it's a bottleneck or not and break from there. The program doesn't do that. When we do the automatic, see there's an automatic partition. It's still based on where you break them in, so that it will give you the maximum, the segment band progression. It's not a considering volume where to break.
Thank you.
I know we are already run over time. Any other questions?
I seen one comment there about ped jump phasing. And I was wondering, maybe we should take a look at the additions of phases 9, 10, 11, 12 that can be assignable, that we can add in to allow for alternate movement, such as a ped jump.
Or the LPI, right?
Yeah.
Okay. Yeah, that's right now we don't have that LPI.
No.
but that can be added. We thought about that. If that's an urgent feature, we can work on that.
Yeah, it doesn't have to be a specific feature for the PEDs. It could just simply be additional phasing that can be assignable to anything we want to put in.
Yeah.
I've got a question.
Yeah.
You mentioned the partition feature only can provide you 2 segments, but if we wanted to break it into more than 2, how would you recommend we go about doing that?
Okay. In that case, you have to let's say this is a long segment. You want to break them here and here. What you need to do is you just need to create a new subsystems. You create a new subsystem for this one, okay? And then you create another, okay, let's say this is called 1, okay? So we create one subsystem 1. Then you create another subsystem, by including that intersection, and then you call it 2. Okay. So now you can open the 2 time space diagrams, at 1 and 2. So here, okay. So now you got 2 time space diagram, and see one of them. Okay, so yeah, this one is the common one. So this is, you probably have to do this way. You optimize this, right? You optimize this, and then so now you want to fix this, lock the offset or sequence. So don't touch this one. Then you optimize the other one.
I think you have to lock Durango
Okay.
since it's on both.
Yeah, something to run.
Because Durango's on the top on your left screen, and then Durango's on the bottom on your
I see.
right
I
screen.
see.
Yeah.
Thank you, Ryan. Yeah, you're right. That's why I was wondering why this changed. Okay. Good point. Yeah, you shouldn't lock this one. Wow, you're good. So you lock this one. Okay, then you optimize. Then you won't affect the other one. Good catch. See? So you fix this one and then you optimize this one. So probably you have to do this way.
Okay, great. Thank you. That's helpful.
Only is there a way to customize the timing parameter output sheets?
Yeah, I found that feature is very useful, but this simply gives a simple printout of default. I want to make it a little bit more attractive if possible.
We can, yeah, we can definitely do that. I will tell you what we are working on now. Okay, for those really advanced users. Okay, if each intersection has different plan and they are not in the same time. So one AM starts 6 o'clock, the other AM starts 7 o'clock. Okay, so currently we have to create multiple timing plans to make that trick. So what we are working on now is to be able to pull out a timing plan based on a user specified time. Let's say you open a like here right now you got this many timing plans created. So user can specify, show me a timing plan that is running between 7 to 8. And we'll search each intersection, look at the schedule, and pull out that one. Okay, so that's the one thing we are working on now. Okay. The other feature is to be able to copy an intersection to a new location. Because if you create something from scratch, this is the main corridor, you want to create a signal here, they may share some common parameters like the yellow, the red, the cycle, and will allow you to copy one and just paste, so that you don't have to always manually put that. So these are the things we're working on now. I think by next user group meeting, we should have that ready, both the schedule and that feature, copy feature. Okay, if there are no more questions, thank you everybody. Thank you, David, for the good presentation. And if you have any questions, you can always reach out to me. Any recommendations, suggestions, and how can we improve? Feel free to make a list and send that to me.
Thank you so much.
Thank you, guys.
Yeah, thank you,
Good
everybody.
job, Dave.
Take care.
Okay, bye-bye.
All right, we'll talk to you guys soon.
Bye-bye.